Okay, next we're going to talk about ions and ionic compounds. So let's remember that in an element or an atom, you can change the number of neutrons, but you can't change the number of protons. You can also change the number of electrons. Changing the number of electrons gives you different charges of a particular element or an ion. So if you have, sorry, let me go down here. If you have fewer electrons than what you would normally have, then that's going to be a positive charge, or a cation. So a positive charge is due to a loss of electrons. That feels really weird. And the reason why is because, remember, electrons have a negative charge to them. They're not positively charged, so that's the reason why. When you subtract a negative, it becomes a positive, okay? Now, when electrons go up, so in other words, an element gains an electron, then that's going to be negatively charged, or an anion. I like to say it this way. So if you think positively about your cat, or the fact that it has a T in there might give you a clue, those are the ones that are positively charged, okay? Electrons want to be in a filled shell. So if you look at a periodic table, these noble gases over here have a full shell, okay? So everybody's trying to be like them. Everybody's trying to be noble, okay? And that's part of why we're going to change the number of electrons. So if you consider that this guy is full, sorry, I can't fit the whole thing on the next. So this is number 18. Let's go to number 19, which is potassium over here, right? He has one more electron than what was like perfect. So he doesn't really want to keep it that much. And he's like, hey, see you, bye, right? And when he kicks that thing out, then he gets a positive charge, because a loss of a negative charge results in a positive charge. Okay. So I'm going to follow along here. So that's potassium. He has one electron in his outermost shell. We call those valence electrons. Valence electrons are going to be very important in this little section through here, okay? One valence electron, two valence electrons. He also is pretty close to being like argon, number 18. Calcium is saying, hey, I've got two electrons that are kind of out there and annoying. I can get rid of those pretty easily. And when I do, I have the perfect configuration just like this. So in other words, he has two valence electrons that he doesn't really want that much. He's ready to give them away. So when he gives them away, he's going to have a charge of +2. Now let's go through the other side. Let's talk about the other side. So let's say that you're chlorine, you're number 17. He would be one away from being perfect. So he's kind of like, hey, please just give me one more, okay? And he says, I will be willing to take anything that anybody's going to give me. And so he wants to get one more electron. And when he does that, he can be just like Ar, or argon, as far as his electron shell is concerned, right? So by gaining an electron here, you actually have a -1 charge on this chlorine. In the same way that we did the last one. Sulfur would have 6 valence electrons. Let me count that for you. Let's start with sodium. Whoops, sorry. 1, 2, 3, 4, 5, 6 valence electrons. He wants to be like argon. Argon has 8. This is where the octet rule comes in. Sulfur wants to gain 2 more electrons. So if he gets 2 more electrons, he would have a -2 charge. So another way to remember this is the positive starts on the left-hand side, the right-hand side is the negatively charged, excuse me. So let's look at my really bad drawn periodic table. Up here on the top I wrote the number of electrons in the outermost shell are valence electrons. This has 1, 2, 3, 4, 5, 6, 7, and 8. Everybody wants to be like a noble gas. So over here they do that by losing one electron. So this entire group, when it undergoes ionization, or it is an ion, has a +1 charge. This entire group wants to lose 2 electrons, and it does so by getting a +2 charge. Over here, you kind of skip the transition littles. We'll talk about that in a second. That's going to have a +3 charge. Okay. Number 4, we'll come back to in another day. Essentially, they don't like to undergo positive, negative very much if they can help it. They do, but you don't need to know that so much. Here is the noble gases, so they don't do anything. Remember, everybody's trying to be like them. The 7 electron valence electrons, they want to get one more, and that's why they get a -1 charge. Those with 6 valence electrons want to get 2 more, so they're a -2 charge. And then the -3 charge is the ones that have 5 valence electrons. So on a periodic table, that means that this group would have a +1 charge, +2, +3. Over here, this one's perfect, so we don't count this one. -1, -2, -3. Okay. So, now that you know how to do that, let's try to figure out how to write a compound. Now, there's ionic compounds, there's covalent compounds. Ionic is what we're going to talk about right now. In a little bit, we're going to come back and talk about covalent compounds, okay? To write an ionic compound, and this will make a little bit more sense in just a second, you first start by determining the charges of all the ions that you have, which that's why I taught you that first. Great, so you know how to do that. Then you're going to determine the combination of ions that would have an overall charge of 0. Here's why. The universe tends to balance charge. If you have a buildup of charge, like you do in a thunderstorm, of electrons in the clouds, that's when you have this big discharge of energy, such as lightning. Since we don't want to live around a whole bunch of lightning nonstop and, you know, coming from our fingers and crazy stuff, although superhero sounds good, but not necessarily like that. The entire world tends to balance out in the universe to have a charge of 0. And so formulas are going to be, or compounds are going to have a 0 charge overall. We write the cation first and the anion last. And that kind of makes sense if you look at the periodic table, because remember, the positive charges are on the left, the negative charges are on the right. So that makes sense to us, I hope. And we use subscripts to tell us how many of each ion we need. If there's not a subscript, it's assumed to just be 1. Okay. So let's look at some examples here. It's easy to start off with Na and Cl. Na plus and NaCl minus, they balance out. Everything's good, right? That would just be NaCl. But when we have Ca plus 2 and Cl minus, that takes 2 of the chlorines to match this positive charge. So we need 2 minus 1s to equal 1 positive 2, because plus 2 times minus 1 is equal to 0, right? And that's why the formula goes Ca, Cl, and then there's 2 of them. Okay. Well, there's a trick. If you want to use the trick, you can use the trick. You don't have to use the trick. It's up to you. Aluminum has a +3 charge. Here's where I got this, remember? Okay, aluminum's right here. +1, +2, +3. When I combine that with oxygen, over here, -1, -2. Okay? So there's my 2 charges, +3 and -2. One of the things that you can do to make this real simple and really fast to figure out what type of compound you have is simply flip these two. You leave off the charges, but you just say Al2O3. Now, the reason why that works is because it still balances out. It's kind of like a lowest common denominator mathematical operation, okay, that you've done probably since grade school. Plus positive 3 times 2 of them, because we just said that that's 2 of those plus 3 things, is 6. And negative 2, which is what oxygen is, times 3 would also be 6. So hey, guess what? Or negative 6 rather. So those two balance out. Okay. Now be aware that sometimes you'll have something with more charge, like magnesium. Let's look at magnesium on the periodic table. We find magnesium right here, so it's going to have a +2 charge. And as we just did with oxygen, it's going to have a -2 charge. So if I were to combine these two, be careful, that rule doesn't necessarily work as well. Because these cancel out, and it would simply be MgO and not Mg2O2. Okay? Let's see. Needless to say, you need to practice these. So I'm going to show you a worksheet that I've made, and I want you to try it right here. Okay? Try that, and then I'll show you the answers. So pause the video right now, and now I'm going to show you the answers to those, okay? Here we go. Oh, I just did Mg and O, which I just did earlier. Sorry about that. I didn't remember that it was there. So this becomes MgO, and we haven't gotten to naming it quite yet. So Be and Br becomes BeBr2. K and I becomes Ki, and Na and S become Na2S. Okay, good. Now,